Okay, this is the last section of Chapter 8, Part 1 of Simplifying Polynomials. Today we're doing the same thing as we did in 8.3. We're foiling, but these are special products. Some pairs of binomials have products that allow a specific pattern. So what's different about today is just notice the patterns. If I have the same thing added, okay, you get two in the middle that are the same that are positive, but if they're subtracted, you get the same thing in the middle twice, but it's negative. So same thing, but the middle is negative versus positive. So let's deal with the positive ones first to show that. You're going to have x plus 6 times x plus 6, and you're going to FOIL just like you did prior. Okay, and you're going to have a 2x plus 7y times a 2x plus 7y. So we're just noticing patterns. Math is all about patterns. So x squared plus 6x plus 6x last 36. I'm going to do the same thing over here. 4x squared plus 14xy plus 14xy plus 14y squared. Now when I multiplied this one, it was yx, but I just rearranged it xy. So notice here, plus plus, plus plus, plus plus. Put them together, it's two of them, right? Two of them is a 12. Two of them is a 28. So we're just noticing patterns. It's no different than the one prior, the lesson prior. Okay? You didn't even need to do this lesson to be able to do these. The specifics about today are, do you notice a pattern? Yes, you do. Okay, these two are subtractions, so we're going to do the same thing. 8 minus m twice. When something is squared, it's that factor times itself. So we're going to FOIL again. First, outer, inner, last. First, outer, inner, last. So do we have a positive minus minus positive? Positive minus minus positive. Yep. So once again, we're going to have two of the same, but they're going to be negative because we're adding, not multiplying. Same thing over here, two of the same, but they're negative because we're just combining like terms. Nothing too profound, it's just noticing a pattern. Here, what if we have a positive times a negative, but a and b are the same, like an x, a 5, and a 5. One's positive, one's negative. What's going to happen to that middle term? Well, we see here you're going to have a positive amount and a negative amount, and they're just going to cancel or simplify, so there's only two terms left. This is called the product of a sum and a difference. So here, x squared minus 5x plus 5x minus 25. They're all going to get the same pattern. So if you notice, go ahead and just start FOILing all of them. Pause the video and then come back. Okay, so notice we had plus minus, minus plus, minus plus, plus minus. It doesn't matter the order. You're still going to get the same result where the middle terms cancel. So you're left with the difference of two perfect squares. The middle terms cancel. So you're left with the difference of two perfect squares. The middle terms cancel. So you're left with the difference of two perfect squares. And you keep hearing me say the difference of two perfect squares. Okay, this is supposed to be negative, that's why. The difference of two perfect squares. What's the square root of 25? 5, 5. What's the square root of 1? 1, 1. What's the square root of 9? 3, 3. So it's the difference of two perfect squares. 4 is 2, 2. 25 is 5, 5. Noticing the patterns. That's all we're doing today. We're still foiling, but we're noticing a pattern. Okay, on the back is more challenging problems. It says find the area of the shaded region. So the area of the shaded region is the big minus the white square. Okay, so the big square is an x plus 2 squared minus the white, which is an x minus 1 squared. So it's squared because it's something times itself. So here if we FOIL, we get x squared plus 4x plus 4. How did I do that? Well, x plus 2 times x plus 2, if we FOIL, and then we combine like terms, that's what we get. Minus this quantity we get when I FOIL x minus 1 times x minus 1. When you FOIL it, you're going to get x squared minus 1x plus 1. So combine like terms, and this is what you get. So I want to subtract that white square. This is that white square. So it's going to be x squared plus 4x plus 4 minus x squared plus 2x minus 1. We had to distribute that negative. Then cleaning that up, these are going to cancel. This is going to become a 6, and a 4 minus 1 is a 3. That was a lot. So you need to rewatch it. That's fine. Let's reiterate or go over again. To find the area of the shaded region, I need to take the area of this square, which is x times x plus 2 times x plus 2. When I FOILed it, that's what I got. I have to subtract the white square to get the shaded region, so I have to remove this, which is x minus 1 squared, which when we FOILed, we got this, and then we distribute the negative to each term. So that minus that gave us that. We're going to do the same thing with triangles. So find the area of the big triangle and subtract it from the area of the square. All right, the area of the triangle is 1/2 base times height, minus the area of the square, which is x minus 3 times x minus 3. So when I FOIL that, I get x squared minus 6x plus 9. When I find the area of the triangle, the base is 1x, 2x, negative 3, positive 5 is a positive 2. So you had to figure out the base. The height is a 1x, is a 2x, and then a positive 6 and a negative 3. This is trickier. So let's FOIL these first before we bring in the 1/2, and we get 4x squared plus 4x plus 6x plus 6. And then we have to take half of that. But don't forget about your other white square that you have to remove. When I distribute the 1/2, I'm cutting everything in half. Well, this is going to be 10. So half of that is 5. Plus half of 6 is 3. Subtract each term. So it's going to be 2x squared minus 1x. 5x, 6x is 11x. 3 minus 9 is 6. Okay, once again, we wanted to find the area of the shaded region. So you find the area of the entire triangle, which is 1/2 base, 1x, 2x. And that 2 comes from a negative 3 and a 5. Here, the height is a 1x, a 2x, a 3, a negative 3, which is a 3. We have to FOIL and then cut everything in half. So that's the area of this triangle. We subtract the white square to find the shaded region, which is an x minus 3 times an x minus 3. When we FOIL, this is what we get. Then we distribute the negative to each term, and this is our overall result. We're talking about areas here, so we should really say units squared. Units squared. At the bottom, this is a little more intense. I don't care which two you pick, but you got to FOIL them first. I picked the last two because I want to leave the c plus d here because it just is easier visually for me. C times c is c squared. C times D is CD. D times C is DC, or another CD. D times D is D squared. When I clean it up by combining like terms, I get C squared. 1 CD, 2 CD is 2 CD. Or I should have said another, not 2. All right, and now I can FOIL or distribute again. It's not really foiling, it's just distributing. Foiling's when you have 2 and 2. C cubed plus 2C squared D, because we have 2 of them. C times D squared is CD squared. All right, 1, 2, 3, 1, 2, 3. Now D to C squared is a C squared D, and then a 2CD squared, and then a D cubed. It's intense. Now go through. C cubed, there's no other C cubes. Is there any other C squared Ds? Oh, there's another C squared D. So now we have 3 of them. Do we have any other D squareds? 1 CD squared, 2 CD squared. So that's a 3C D squared, and then a D cubed. And that's it. All right, here, we're going to square this one first. Or we could square the last 2 first. It really doesn't matter. Let's just go with the back 2 so we can rewrite it pretty. And I get n times n, p times n, negative p and n, and negative p squared. Okay. I also picked these 2 because one's a positive and one's a negative, and I just learned on the front that the positive and negative will cancel, so it's an easier polynomial to work with. And now I'll just FOIL again. First, outer, inner, last. N cubed, there's no other. There's a p squared, there's an n squared. They can't go together. And then p cubed. And that's it. So if you're like overwhelmed by the back, this is more to push you. Okay, this one we should be able to do. The other ones are just, they might be challenging, and that's okay. But this, we should be able to get the front no matter what, because it's just simply foiling. If you have any questions, feel free to ask.